So today we're going to be looking at the derivatives of inverse functions. So since we're taking the derivative of an inverse function, our inverse function is going to look like f inverse. And what we're going to be doing is we're going to take the derivative of that. So if you recall, we actually had a formula for this. The derivative of an inverse function of x is equal to 1 over f prime of f inverse of x. And it's really important to memorize this formula or memorize the proof of where it came from, because it helps us with each of these problems. So number one says, let f of x equal 1/4 x cubed plus x minus 1, with f of 2 equals 3. Now, if they gave me this point, it's probably going to be important later on. Question is, what is the value of f inverse, the derivative of that, of 3? Well, we're going to start off by using that formula. Since it's asking for this, here's f inverse, and I'm looking for the derivative of that at 3, all I need is 1 over f prime of f inverse of 3. And in order to simplify this, we're going to have to work our way from the inside out. So we're going to start off with saying, okay, what is f inverse of 3? Well, that question alone asks this. F of what number is going to give me 3? Since 3 here represents a y value, in this case we're asked f of what x value gives me 3. Well, in the directions, they told us f of 2 equals 3. So we're going to use that to write 1 over f prime of 2. Now the next thing is find f prime of 2. Well, in order to find f prime of 2, we need to find what the derivative of f is. That's not that difficult. Since we know f of x equals 1/4 x cubed plus x minus 1, and that's just a polynomial, we can use the power rule. F prime of x equals 3/4 x squared plus 1. Now I need to find f prime of 2, which means plug in 2, so 2 squared is 4, plus 1, that's going to equal 4. So then this turns out to be 1 over 4, because f prime of 2 is equal 4, so there's my answer, 1/4. Now if you take a look at number 2, it looks very similar. It says f of x equals x cubed plus 2x minus 1. Find f inverse prime, so the derivative of the inverse function, at 2. The one thing that's missing that was available in number 1 is that point, f of 2 was equal to 3, was given to us. It's kind of like a key to unlock the problem. In this case, I'm not given that key. So we're going to start this the same way. This right here is the derivative of the inverse at 2, which is 1 over f prime of f inverse of 2. Now, same as the last problem, we have to work our way from the inside out, and we have to find f inverse of 2. Well, just like the last problem, it's saying f of what value is going to equal 2. In this problem, I actually have to do the work in order to find what that value of x is. So what I'm going to do is I'm going to write, okay, 2 equals x cubed plus 2x minus 1. Now, since this isn't a quadratic, nor is it anything I can solve using plain old algebra, if I want to solve this type of problem, I'm simply just going to refer to the calculator. So I'm going to plug 2 into y1 and f into y2 and find their intersection. So if I open up a calculator, So going to y equals, the left side is equal to 2. So in y1, I'm going to plug in 2. And in the right side, it's x cubed plus 2x minus 1. So I got to type that in. X cubed plus 2x minus 1. I'm going to graph it. And then I'm going to hit second trace intersection. And then I have to hit enter 3 times. Enter, enter, enter. And if I look at what it says the intersection is occurring at x equals 1 and y equals 2. Therefore, this question right here, which I asked earlier, f of what equals 2, now we know the answer to that. We now know f of 1 is equal to 2. So therefore, I can continue this equation by saying now I know what f1 over f prime of 1 is. And then now in order to find f prime of 1, I have to find the derivative just like in problem number 1. So f prime of x will be using the power rule again. 3x squared plus 2. F prime of 1 equals 3 plus 2, which equals 5. So the answer is 1/5. Okay, for number 3, it says, find the derivative of the inverse of f of x, if that equals x cubed plus 7x plus 2, at the point where f inverse of 10 equals 1. So the nice thing is it didn't tell us exactly what we're finding, but it did give us this key that's going to help us unlock the problem. And it just tells us where this occurs. So what we're really looking for, the problem is saying, find the derivative of the inverse at 10. Well, we use our formula. 1 over f prime of f inverse of 10. Step by step, we can find out that this is 1 over f prime of f inverse of 10. This inside piece tells us this right up here, that's going to be 1. Now I have to find f prime of 1. So really quickly on this side, f prime of x equals 3x squared plus 7. So f prime of 1 equals 10. So the answer is 1/10. For the last problem, try this one on your own, pause the video, and see if you can get to the correct answer. It's the same problem we've been doing, but the wording may be a little different. So this time, try pausing the video and try to do it on your own. Did you get the answer 1/4? If yes, you got it right. If not, let's go through it. So let f be the function defined by f of x equals x cubed plus x. G of x is the inverse of f. That's really important to understand. G is the inverse of f. So anytime I see g, I'm really just talking about the inverse function. And we know g of 2 equals 1. Immediately, because they gave us this function, f of x equals x cubed plus x, and then this tells me a point on g, instead I'm going to use this and I'm going to rewrite it using this. So if it says g of x equals f inverse of x, if I plug in 2, I should figure out what that equals. So g of 2 equals f inverse of 2. Well, g of 2 is written right up here. So that means f inverse of 2 is equal to 1. Now there's our key to unlock the problem. So now it says, what is the value of g prime of 2? Well, again, g itself is equal to f inverse. So when I'm looking at this and I see g inverse, when I see g prime, I'm really seeing f inverse prime of 2. And right now, since we're taking the derivative of an inverse function, I'm going to have to use my formula. 1 over f prime of f inverse of 2. F inverse of 2, right up here. So f inverse of 2 equals 1, so that means I now have 1 over f prime of 1. In order to find f prime of 1, I'm going to have to find the derivative. F prime of x equals 3x squared plus 1. F prime of 1 equals 3 plus 1, which is 4. So therefore my answer was indeed 1/4.